Recursion and financial modeling. Question 7. Phil is a builder who has purchased a large set of tools. The value of Phil's tools is depreciated using the reducing balance method. The value of the tools in dollars after n years, Vn, can be modeled by the recurrence relation shown below. In Part A, we are asked to use recursion to show that the value of the tools after 2 years, V2, is $48,600. Let's start with V1 equals 0.9 V0. Notice that we substituted n equals 0 in the recurrence relation. So V1 equals 0.9 times 60,000, that is $54,000. Similarly, we are going to substitute n equals 1 in the recurrence relation, so we have V2 equals 0.9 V1. That is V2 equals 0.9 times 54,000, which is 48,600. Note, since the question is stating use recursion, the method shown above must be used. The use of the formula V2 equals 0.9 squared times 60,000 does not use recursion. Part B. What is the annual percentage rate of depreciation used by Phil? Notice the 0.9 in front of Vn. That can also be written as 90%. So, since the value of the set of tools depreciates to 90% of the value in the previous year, it means that it depreciates by 10% per year. Part C. Phil plans to replace these tools when their value first falls below $20,000. After how many years will Phil replace these tools? In this question, we are going to use the formula Vn equals 0.9 to the power of n times 60,000. Using available CAS technology, we are going to solve the equation 20,000 equals 0.9 to the power of n times 60,000 for n. So we get n equals 10.4272, so the answer is 11 years. Part D. Phil has another option for depreciation. He depreciates the value of the tools by a flat rate of 8% of the purchase price per annum. Let Vn be the value of the tools after n years in dollars. The question is asking to write down a recurrence relation in terms of V0, Vn plus 1, and Vn that could be used to model the value of the tools using this flat rate depreciation. First, we are going to calculate the flat rate of 8% of the purchase price. So 8% of 60,000 is equal to 8 over 100 times 60,000, which is equal to 4,800. Now, V0 equals 60,000, so Vn plus 1 equals Vn minus 4,800. Question 8. Phil invests $200,000 in an annuity from which he receives a regular monthly payment. The balance of the annuity in dollars after n months, An, can be modeled by the recurrence relation given below. Part A. What monthly payment does Phil receive? To calculate this monthly payment, we are going to look at the recurrence relation, and we see that $3,700 comes out of the account, which means that this is the monthly payment. Part B. Show that the annual percentage compound interest rate for this annuity is 4.2%. If we look at the recurrence relation, we have the number 1.0035 in front of An, which means that the annuity increases by 0.35% per month. So we calculate the annual percentage compound interest rate by multiplying 0.35 by 12, and that is 4.2% as required. At some point in the future, the annuity will have a balance that is lower than the monthly payment amount. Part C. What is the balance of the annuity when it first falls below the monthly payment amount? Round your answer to the nearest cent. Best to use Finance Solver on available CAS technology for this question. In step 1, we are going to calculate the number of months it takes for the future value to be 0, with the interest rate of 4.2 per annum and the principal 200,000 and the payment per month 3,700 and 12 paying periods per year. So n is more than 60. In step 2, we are going to calculate the balance of the annuity after 60 months. So the future value after 60 months is $92.15. So that is the last monthly payment. Part D. If the payment received each month by Phil had been a different amount, the investment would act as a simple perpetuity. What monthly payment could Phil have received from this perpetuity? Remember that in a perpetuity, the monthly balance of the account is always the same. So we can calculate the payment for 1 month. So the monthly payment for a perpetuity would be $700. Question 9. Phil would like to purchase a block of land. He will borrow $350,000 to make this purchase. Interest on this loan will be charged at the rate of 4.9% per annum compounding fortnightly. After 3 years of equal fortnightly repayments, the balance of Phil's loan will be $262,332.33. Part A. What is the value of each fortnightly repayment Phil will make? Round your answer to the nearest cent. We are going to use Finance Solver on available CAS technology. For the number of periods is 3 times 26 because there are 26 fortnights in 1 year, so that is 78. Interest rate per annum 4.9%, present value $350,000, and future value $262,332.33. Notice that this has a negative in front of it because it's still owed. And the number of payment periods per year is 26. So the fortnightly payment is going to be $1,704.03. Part B. What is the total interest Phil will have paid after 3 years? Round your answer to the nearest cent. First, we need to calculate the total amount paid over the 3-year period, and that is $1,704.03 times 78, which is $132,914. We can also calculate the principal reduction, which is $350,000 minus $262,332.33, and that is $87,667.67. We can now calculate the interest paid, so we take away the principal reduction from the total amount paid, and that is $45,246.67. Part C. Over the next 4 years of his loan, Phil will make monthly repayments of $3,517.28 and will be charged interest at the rate of 4.8% per annum compounding monthly. Let Bn be the balance of the loan and months after these changes apply. The question is asking to write down a recurrence relation in terms of B0, Bn plus 1, and Bn that could be used to model the balance of the loan over these 4 years. The annual interest rate is 4.8%, therefore the monthly interest rate is 4.8 divided by 12, which is 0.4%, or 0.004. So we start with B0, which is $262,332.33. Bn plus 1 equals 1.004 Bn minus $3,517.28.